Hello, welcome back to NMI. A couple weeks ago, I was organizing some of my Atari ST stuff, and I found this joystick that came with a lot I acquired earlier this year. I did not pay too much attention to it before, since I thought it was just another joystick, albeit unusually large in a metal case and with more buttons than ordinary joysticks. And since it was wiggling a little bit, I decided to open it up to straighten it so it would not wiggle anymore. When I opened it, what I found completely blew my mind. And this is what I'm going to share with you in this video. But before we proceed, what about giving me a thumbs up and subscribing to NMI? This is going to help the channel to grow and encourage me to make more videos like this. Thank you. This is the joystick I'm talking about. This is the MicroFlyte ATC, manufactured by this company, Microcube Corporation. You can see it's an unusual joystick, let's put it this way. It's a metal case, right? It has more buttons than ordinary Atari, for instance, joysticks, the ones that were commonly used on Atari's, Commodore 64 and Amigas. But it is compatible with those joysticks. You can see here the connector. It uses this stick, and the stick here seems to be analog, so that's another difference compared to all other joysticks for those machines that use like digital sticks, right? And the other thing that caught my eye was this reset button. So that tells you that there is something inside, because why do you need a reset? So this is it. Now it's time for us to open it, and I am going to show you what is inside. But the one last thing I wanted to say, this joystick, I could not find a lot of information on it. I know that apparently there were models manufactured for the Atari ST and Amiga, and also for Commodore 64 and Atari 8-bit, Atari 400 and 800. I don't know any other information. And also the fact that these joysticks, mostly they were designed and sold for using with the Flight Simulator 2. So the audience was very small, right? And maybe this is one thing that I don't know how successful this was. I am guessing it wasn't very successful just because the audience is very small. Now, let's take a look and see what is inside. Okay, so here we have the joystick. I'm gonna open it. There are 4 screws. Here, 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 and here. Wow, look at this. So this is basically a computer. This is the CDP-1802, also known as COSMAC. We have an EEPROM here with the code that makes the joystick work, and we have a 2K static RAM. That is unbelievable, right? I mean, I was never expecting to find such a complex circuit, and especially a COSMAC inside a joystick like this. So this is pretty amazing. Now, one thing that I want to do is to make a copy, like extract the code from this EEPROM, just in case, because I try to find some image of this EEPROM and I couldn't find. So I think it's always good to give back to the community, right? And then that is something that I want to do now. Now, why am I so excited about the CDP-1802? Well, This is one of the very first 8-bit single-chip microprocessors, and probably the first one manufactured in a CMOS process. It was designed by RCA. The CDP-1802, also known as COSMAC, had some very interesting features, such as it was a single voltage device, internal DMA that allowed direct bootstrapping without an external ROM, 5 direct I/O pins, 1 output and 4 inputs, static design that could operate from 0 Hz up to 3.2 MHz, and a very low power consumption, about 4 milliwatts idling. But it was not very fast, and the instructions could take anywhere from 8 up to 24 clock cycles. The COSMAC became very popular due to this article published by Popular Electronics in August 1976. And it featured this very low-cost computer called COSMAC-Elf, right? And as we can see here, it was deemed as a low-cost experimenter's microcomputer, and indeed it is. It had only 256 bytes of RAM, a couple switches, a few CMOS ICs, and that's it, right? The design relied on the ability of the 1802 to DMA stuff directly, so you could read the switches and populate or fill in the contents of the RAM, which is pretty cool, right? Other features like the internal oscillator and the very simple design of the 1802 made this resulted in a very affordable computer back in the mid-70s. We can also see the instruction set that was published on the same article. Very few instructions that you can get started and do a lot of things. That is also very nice. The article has this introduction to programming. Again, this is 1976, right? Programming was extremely new. People were not used to computers at all, right? And especially microcomputers. They even have here a quick example of a program that counts the number of times the input switch is operated. Yeah, pretty cool. That makes me want to build one, and I probably will. Let's see. You will see in the future. So I think the COSMAC-Elf played a very interesting role on introducing people to microcomputers, especially affordable microcomputers, right? We can see here in this article that the 1802 was sold back then for less than $30, right? Which might seem a lot in 2025 for an old microprocessor, but back then that was a real deal. While the COSMAC was not a commercial success in the microcomputer market, which was its main focus, its low power consumption was very appealing in the embedded market. Not only that, the COSMAC was selected as the main microprocessor of the Unified Data System, UDS, which was the main controller of the space probe Galileo. Isn't that cool? Funny enough, according to documents from NASA, the COSMAC was nobody's favorite choice. But in 1977, it was considered the only microprocessor suitable for spaceflight. So my MicroFlyte ATC joystick uses the same kind of microprocessor that flew to Jupiter. Isn't that extremely cool? So just a closer look on the circuit. So we have the analog joystick here. We have the switches. There are some diodes there. That is the
LED there, right here. This is the reset switch. And here on the circuit board we have the CDP1802, an EEPROM, static RAM. This is a 2K static RAM, 6116, and some CMOS ICs, 4042, 4042, and 4011, and a crystal. That's a pretty simple circuit. Now I'm just gonna extract the code from this EEPROM and preserve it, you know, just a way to give it back to the community and make sure that if anyone else, or maybe even myself in the future, right, this EEPROM is gonna die at some point. It's gonna lose its programming, so it's a good idea to make a copy and have that stored for future use. Now I'm gonna remove this EEPROM and we're gonna use a programmer to copy it. This is a 24-pin memory, and it's either a 2716 or 2732. So I'm gonna try reading it first as a 2732 and see what happens. Worst case scenario, we're gonna read all zeros from the upper half. So the fact that pin 21 here is connected to VCC, right? And also that we have 2K of RAM here, that means to me that this memory is probably also 2K, right? And because if it was 4K at 2732, this pin should be connected to an address line, and it isn't. So this is most probably a 2716. We don't have to remove this label, because even if I try, like, I don't want to remove, like, it's very stuck here. I don't want to damage the chip or, you know, damage even the label. Let's keep it this way. And it's easy enough to figure out which memory is this, right? Now let's close it. When connecting this connector back, there's a small notch here, right here, and the socket is also has a notch here. Well, all ICs, they're pointing to this direction, right? So that is the hint that you need in case you remove this guy and you don't know how it was connected. This is the way. I'm gonna do some cleaning now. Let's first patch all the screws back. Okay, this is it. I think I'm done. I'm not gonna try to clean it up any further because I'm afraid that I can remove the, you know, all these markings here, and I don't want that. So this is gonna be it.
Now all I have to do is to make it work. It can't be rocket science, can it? Okay, so we have the joystick here. I have a Goldtech, external Goldtech connected here, and I have Flight Simulator there. The joystick is connected to my mouse master here. Right now, and it goes into the mouse port, right? So it's shared with the mouse here. I have an adapter here from to connect a USB mouse. So let's open let's start Flight Simulator. This is Flight Simulator 2. And fortunately, I found the manual, well, the leaflet, right? And here I learned, because the first time I tried this joystick, it was not working at all. And the reason is the reset button here, right? The way this joystick works. Oh, it's already in demo mode? No, I don't want demo. The way this joystick works, according to the manual, you need to long press reset for about 4 or 5 seconds. And then the system initializes. And then there are 3 modes. You press once, and you are in like the ordinary joystick mode. You press twice, and you are in the proportional mode. And if you press 3 times, then you can adjust the sensitivity. So let's see. I'm gonna switch mouse master to joystick, and I'm gonna long press reset for about 5 seconds. And if I press once, see, now the joystick is controlling the mouse, right? If I press this button here, we switch on and off the cursor. But if I press twice, that is the most important mode here because it's a flight simulation. If I press twice, then we have the proportional mode like this. Yeah, you can see it's not perfect, right? If I switch off the cursor, oh, why it's not switching off? Once. Okay, now twice. If now in this proportional mode here, we can see that I can control, and the system is now in yoke mode, right? What I found is that the best way to use this system is to switch it to, or reset. First, we switch to joystick mode and centralize all the commands, right? Here and here. And then we switch to proportional mode, and it should work fine. I'm also gonna switch back to mouse and adjust here the sensitivity for the elevator and the aileron. Now we're good to go, I hope. So what I'm gonna do is, now we're back to the joystick, yeah. Now if you long press the throttle, these 2 switches here, you can increase and decrease the throttle. And take off. I found that it's not very easy to, oh no, you don't want to hit the ground. It's not very easy to find or to adjust the joystick properly. That is, I don't know, maybe it's me, maybe I need to spend more time adjusting it. I tried the third mode where you can control or adjust the sensitivity here on the joystick, but I was not successful. What is that? There's a bridge over there. And obviously the graphics are very dated, right? This is a 16-bit machine, very old flight simulator, but it's pretty cool that it works, right? And with this joystick, I believe, well, it's easier than controlling it on the keyboard or using a digital joystick. I mean, a traditional joystick for the Atari, which is digital, right? So you have only the 4 directions and the switch. Yeah, but the thing is, the joystick is working. I'm happy. It's unbelievable that inside this joystick there is a CDP-1802, a microprocessor with such, a microprocessor with such an amazing history, right? A microprocessor that was used on like spacecrafts, satellites, and all this sort of cool things. And it is also used inside the MicroFlyte ATC joystick. Unbelievable, isn't it? Well, that's it for this video. Thanks so much for watching. Please leave a comment on this video. If you liked it, please hit the like button, subscribe to NMI, and see you next time. Bye. Yeah.